Number 4, find the open intervals, which, let me zoom out a little bit here, which the function is increasing or decreasing, and locate all the relative extrema. Okay, so we got a cubic, it's a polynomial, nothing weird going on, we just kind of do our normal routine. So what do we got? We got, let's just go straight to the derivative, because those are going to be our critical points, and then we'll just see if it's increasing, decreasing. Okay, we'll do the candidate chart. All right, so we got 3x squared minus 6x minus 24. All right, that's our derivative. So let's go ahead and factor out a 3, I see. So take a 3 out. X squared minus 2x minus 8. And then that's going to equal negative 4 and positive 2. Okay, so this means then that where the derivative is 0 is where relative extrema are going to happen. All right, and so we know that this guy increases and decreases without bound. He's a cubic, so there is no endpoints to test, right? There's no closed intervals to do. This is an open interval, right, over the whole domain. So it looks like for this guy to equal 0, the 3 has no effect in the equation. If we divided both sides by 3, it's gone anyway. So we would just say x equals 4 and negative 2. So at 4 and negative 2, all we got to do is just test for increase, decrease. And we're going to look right here to determine this. So let's try negative 3. So negative 3 would give me negative here and a negative here, so that therefore it would be positive. Okay, so it's got to be increasing. In between here would be 0, and so that I can see there negative, positive, so that would give me negative, and then 5 would give me positive again. Okay, all right, so the derivative is a quadratic, and so this is showing you that it's a cubic, right? My original function is a cubic. So this means that the relative max would happen here at x equals negative 2, and my relative min would happen here at x equals 4. Okay, so where's this guy? Now we're just gonna, find the, well, here, minimum happens at 4, and this guy happens at negative 2. My kids are, it's late. Lucas, knock it off. I'm exhausted. Increasing from negative infinity all the way until negative 2. So negative infinity all the way to negative 2. Then it will transition, so it basically goes to 0. But then it increases again after 4, so then that guy will go there. Then it's decreasing in between, everywhere in between. All right, now we just got to figure out what those points are. So here I'll just use the calculator. I'm not going to plug the 4 into this guy, because that would just give me whether or not he's increasing or decreasing at that point. In fact, we'll find that if we plug it into here, it would just be 0. Okay, plug it in here, 0. That would defeat the purpose. We just want to make sure that we've got this. We're going to go ahead and do a third minus 3. I feel like typing on a calculator during the video feels so slow, okay. Is that right? 4? Okay, negative 72. All right, so now we're going to go ahead and copy that, and then we'll put in a negative 2. And we'll start over here, and we'll make sure we do an insert, negative, and then we will not do an insert, 2. And then we will do an insert, negative, and then not an insert, 2. Insert, negative, not insert, 2. And we get 36. All right, there's number 4. Okay, so now same thing, but now we've got this function here. But now we need to know concave up, concave down. So for that, we will go to the second derivative. But we're still going to do increasing, decreasing, and relative max and mins. And then, okay, so we'll do a points of inflection. This is where we're going to see where the second derivative is 0. Okay. Okay, so basically you just want to see how you want to test the accuracy of your results here. So increasing, let's go ahead and just take the derivative here. So we get 3x to the second power minus 8. All right. And so 3x squared minus 8, what we're going to do is we're going to set this equal to 0. Okay, it's not factorable in any way. We're going to have to move the 8 over. Okay, divide by 3, so you get 8 over 3 equals square root. So take the square root, and you get plus or minus 8 over 3. All right, and it's just how it is. So that's our guy, and this is where the derivative equals 0. Okay, so this means that these guys are candidates for the relative maxes and mins, right? All right, so we just don't know, is the positive here, negative there, we don't know. All right, so let's go ahead and do the testing part then. Okay, so we'll put a negative radical 8 over 3. I don't know what that number is either. I should figure out what that is. Radical 8 divided by 3 is 1.63. Okay, so negative 1.63 and then just 1.63. Okay. All right, so with that, let's go ahead and pick a number then. Now I'm just focusing on the first derivative right now. Okay, so first derivative, that'll give me this guy, this guy, this guy, and this guy. Okay. All right, let's pick negative 2. Negative 2 going into here, this derivative, is going to give me negative 2 squared is 4. That's going to be positive. This guy's going up. Okay, so let's go. All right, so this guy's going up. All right, and then this guy in between, my guess is he's going to be going down. We plug in a 0 here. 0 will get negative 8, so he will be negative. Okay. All right, and then we are going to go ahead and pick a number bigger, so 2. Plug in a 2 for 2. Yeah, oh yeah, positive. Okay. Okay, so it looks like this guy then is increasing on these two intervals. Okay, awesome. So we got from negative infinity. Okay, this is a continuous cubic, so he's going from negative infinity to minus, and we'll just leave it as radical 8 over 3. And then he's going to pick it up again on the positive side of things. Okay, you can leave it just like that, totally fine. Decreasing, it's happening in between. So all right, cool. Worry about the concave down in just a second. We can see here that this guy is, this is going to be a max, and this would be a min, okay? But let's go ahead and actually, let's do the second derivative, okay? Second derivative we'll do over here, and that's going to be 6x, right? 6x. So where this guy is 0, it's actually where x is 0, okay? Now, if you think about it too, if you think this is on the positive side, this is the negative side, 0 is right in the middle. So there's like this symmetry that's happening. So that it kind of feels right that 0 would be the location of the point of inflection, okay? So at 0, okay, now if I plug in a negative radical 8 over 3 into here, that's going to give me a negative value, okay? And that means that it would be concave down. This is for the second derivative, right? Concave down. And that's exactly what I see here, right? And then at 0, it transitions. And I bet you when we put in the positive, we're going to get positive. Cool. So then that's going to be positive. This guy would be then concave up, which is exactly what these arrows are alluding to. Okay. So this means that we pretty much got everything we need now. Point of inflection happens at 0. 0 when I plug it in here is 0, -8. Okay. So the point of inflection is 0, -8. I'm not really going in any particular order. I'm just kind of going as I see it. My relative, well here, let's do concave up. Concave up is actually 0 and upwards, so 0 to infinity, okay? Concave down would be -infinity to 0, because that's when it switches over to concave up, okay? And then the relative min is going to be this guy, so he is positive radical 8/3. I don't know what that value is yet, so I don't know why I closed my parentheses. Okay, but this guy's going to be the negative radical 8/3. Okay, and then we just got to plug those in to see what we get. Can I do this? No, I can't, because this guy's not. This would undo the no, this is going to be messy. So let's just use this value there, and we're going to copy this guy. I'm going to raise him to the third power. Minus 8 times that value again, and negative 8.71. And that was at the positive version? Yeah. All right. Now I suppose it's a little weird to have this a decimal and that value kind of his radical. So if you wanted to change this to a decimal, that would be totally fine. We're going to do the same thing with the negative now. I'm going to use this guy. Go ahead and insert negative. Go over here and then insert a negative. Hit enter and I get positive 8.7. And that's kind of nice because I can kind of get a feel for the the symmetry of it all. Okay, so it's kind of a nice little equation here. That guy. So anyways, that's it.